In this video, we are going to look at implicit differentiation, which is a process for differentiating equations that cannot be or only with difficulty solved for y. Okay. And there's a little oddity here, and we have to use the chain rule. It is a basis for the implicit differentiation is the chain rule. We are going to take the derivative with respect to x. Well, later on we'll do it with respect to t when we do related rates. When taking the derivative of y, tack on y prime. And let's look at why that is here in here. So if we want to take the derivative with respect to x of d dx of y squared. Well, this is a problem because this is x and this is y. So we're taking the derivative with respect to x, but our variable in the little expression that we have is y. So what we do is we tack on, we had d dy. We know we can take d dy of y squared. That would be 2y. We tack on dy dx. And the reason for that is because this and this, if you think about these as fractions, those would cancel and you're left with d dx. And so that's why this would equal 2y times dy dx. And that's how we account for taking the derivative with respect to x. Okay, so let's look at an example. Differentiate x squared plus y squared equals 19. So we're going to take the derivative with respect to x of this whole function. So the first one's easy, it's 2x. And now we're taking the derivative with respect to x of y squared, it's 2y, and then tack on y prime. And the derivative of 19 is 0. Now we solve for y prime. So I would subtract 2x, 2y, y prime equals negative 2x, divide by 2y, and so it's negative x over y. Now I have a derivative that I could plug points into, find slopes, etc., etc. Okay. Example 2. Find the equation of the line tangent to the curve x cubed plus y cubed equals 9 at the point 2, 1. Okay, so we want the equation of the line tangent. We're going to use y equals y1 plus m times x minus x1. And so I know that this is 1 plus, I don't know the slope yet, and I'm going to take the derivative because I know that the derivative finds me the slope. So this would be 3x squared plus 3y squared, don't forget to tack on y prime, equals 0. And so if I solve that for y prime, it would be negative 3x squared divided by 3y squared, or negative x squared over y squared. Now I plug in negative 2 squared divided by 1 squared, which of course is 1, that would be negative 4. So my slope here is -4, and there's the equation of the line tangent to the curve at that point, is this right here. Good. So again, we took the derivative with respect to x, tacked on y prime, solved for y prime, and then finally plugged the point in for x and y. Let's look at a third example. One a little more complicated here. Okay. Again, now we see that xy squared. That's going to require the product rule. Because it is two separate functions multiplied together, we're going to have to use the product rule in order to differentiate that. So now we have implicit differentiation along with the product rule. So we're going to take the derivative with respect to x of xy squared plus y cubed equals 35x. Now here it's going to be the first times the derivative of the second plus the second times the derivative of the first, which is just 1. Derivative of x is 1. Plus the derivative of y cubed equals the derivative of 35x. So it'd be x, and the derivative here is 2y, and we have to tack on that y prime to cancel out the dy, plus y squared plus the derivative here is 3y squared times y prime equals, and the derivative here is 35. Okay. Implicit differentiation, tacking on y prime every time we take the derivative of y. Now we want to solve this for y prime, but here we have two terms that have y prime and two terms that do not. So what I need is to get this over here on the other side. I need to get everything without y prime in it over on the other side. So y primes are all together. So I have this. I would subtract y squared from both sides, and I'd have 35 minus y squared. And in order to complete this, I need to factor out the y prime, and I'm going to reorder this here and make it 2xy plus 3y squared. All I did was factor out the y prime that's in both of those terms, equals 35 minus y squared, and then divide 35 minus y squared divided by 2xy plus 3y squared. That is our derivative. So each time we do that, when we're solving for y prime, we have to get everything with y prime on one side and everything without y prime on the other, factor out the y prime, and divide usually. Okay. Let's do another one. This one, we can see we have a chain rule here, sine of x plus y. So we're going to have to do the derivative of the outside times the derivative of the inside. And we also have a product rule on the other side. So I'm going to take the derivative with respect to x of the sine of x plus y equals y cubed sine of y. Okay. So the derivative of the sine is the cosine of x plus y. That's the derivative of the outside because it is a chain rule. And the derivative of the inside, the derivative of x is 1, and the derivative of y is also 1, but tack on y prime. So it's 1 plus y prime equals. Now here I have a first and second function. So I have to do the first times derivative of the second plus second times derivative of the first. So that would be y cubed times the derivative of sine of y plus the sine of y times the derivative of y cubed. A little tight there. That would be y cubed times the cosine of y but tack on y prime, and here would be the sine of y times 3y squared, and also tack on y prime. Now, I'll move over here, save myself a little room. I'm going to rewrite that. Cosine of x plus y times 1 plus y prime equals y cubed cosine of y times y prime plus, I'm going to bring 3y squared out front, sine of y times y prime. Now I have to distribute here, and I'm going to have cosine of x plus y plus y prime times cosine of x plus y, and I'm going to factor out the y prime on the other side. Y prime, and then y cubed cosine of y plus 3y squared sine of y. Now this one has to go over here, so I'm going to do that and factor out at the same time. Cosine of x plus y stays where it is. So all three of these I'll be subtracting, so it'd be y prime, and this would stay the same, times cosine of y, not minus, plus 3y squared sine of y, and then minus cosine of x plus y. And then divide everything by that, and what we have is cosine of x plus y divided by y cubed cosine of y plus 3y squared sine of y minus cosine of x plus y equals y prime. Pretty hefty, a little bit of algebra there, probably a little bit more than they ask you to do on the AP test. Well, good practice nonetheless.